Hi all again. Uh, Remember I was talking about startup performance, right? And I said that there's a blog, you can, it's very detailed and whatnot. So I thought maybe I can share some insights, some tidbits so that you can also think about, okay, how do we deal with React Native startup performance? How do we go to 2x, right? So this is all about that. So this is me just talking about the blog. If anyone loves me. Uh, cool. Background is that I am a front-end engineer. I have been web developer, not into React Native, and React Native is a complex system, right? It's a layer of stuff that even React team is trying to make sure that it's resilient to change, right? It can be stable enough that performance can come. But I was thrown at this problem that our app is very slow, 12 seconds is too much for customers to wait. How can we optimize it? So that's how it started. So how do we go about it, right? This is how. Let me get rid of this. Yeah. So this is how the stack kind of looks most of the times that you'll have your on Android, especially because iOS. Thankfully, it's fast enough that you may not have to worry too much about this performance. But on an Android, you'll have your main activity, you'll have React Native, which will start up, right? Then it will load up all the modules, the JS bundle, which could be if it is in MVs, you imagine that much time it will take to initialize it. Then your app would load. Then you would do things like register app on React Native, right? Then it would boot the first component that you render, and then finally the UI would come, right? See how much distance I traversed. So this is how the pipeline looks like, and almost everyone who has worked with React Native performance would know Ram. Ram has shared excellent talks multiple times about how to take care of it, right? So over here, if you see, yeah, so over here you can see that he's talking about React markers, how you can use it to find where the bottleneck is and whatnot. But I think in practice, what I found is that most of the times the bottleneck can also occur on the JavaScript side if the app is 99% React Native based, right? If you have a brownfield native app that you're converting into React Native, I think native would be much more relevant to you. But I'm assuming if most of you are not yet into React Native or have a React Native app which was just from scratch, chances are the JavaScript bit could be more interesting place to look at. And honestly, that's where my expertise is. I have less knowledge about native, so I thought let me just go about it and see. The first thing that I did was that I wanted to measure, right? There's no clear-cut lighthouse thingy for React Native. There is now. I think it's got Spotlight or something. We'll talk about it. But it's hard, right? And before you optimize, as previously also said, that numbers are very important. Without numbers, you don't even know what you're improving. You might be regressing and you're thinking, oh, I've added this PR and now everything is fast. So measuring is very important. And thankfully, thanks to all the previous developers at Rodang, they had put some great telemetry, so we could use Spanner and whatnot. But that was giving this number which I could not make sense of. That sometimes I was saying 30 seconds, 1 minute. I was confused that 1 minute to load the app, that doesn't add up. So I took out a Snapdragon 720 something phone, and I tried to do just a simple, very real user experience of starting the app from scratch, right? So here you can see that I'm opening all these random apps. They are not related to each other particularly, but to get an idea of where does RR stand. And I could see that, oh, it's not bad, not good, not bad. Amazon is 2 seconds, less than 2 seconds. Wow. Amazon is less than 2 seconds, as you can see. Let me freeze it here. Big Basket is 2.8, Slack is 2.8, Udang was 3.3, and as we go on, like Notion is 10 because they do crazy stuff with their views. So it looked fine to me. So I was confused at what is the metric that we're looking at then. So I talk a lot in the blog, but ultimately then I thought, okay, let me just measure what happens in the app. Okay, if this video is not telling me, maybe I can find which is the longest bar and then I can optimize it. So over here you can see that I just literally console log, nothing else, on a local test to see what is happening. So here I saw that okay, native package takes 200-300 milliseconds on my local build. Then I can see that JS bundle will take some time. Obviously on local it will be slower because it's not a production app. And then you can see that code push, wrapper, and Redux, it's taking close to 800 milliseconds. That makes less sense. And then again, configuration in it, that's also taking a lot of time. And this, as you can see, it's starting to resemble a network waterfall, right? Even the native does not have to worry too much about network waterfall. The latency is not on the network side, but on talking to the device itself. So here, this is when the person tapped the app icon and they went through this waterfall. Our goal would be like any other waterfall, see what can be done before, see what can be done later, see what can be done in parallel. That's how you optimize it. That I know as a web engineer, right? Okay, makes sense. Then I went ahead and over here I saw that these two things, right? Configuration was taking too much time and this Redux bundle something was taking too much time. So here I saw that, okay, the session over here, this is the breakdown of that config. I broke it down again, saw where is it actually the bottleneck coming from, and this session was taking too much time. And if you think about it, this is quite bizarre that we had our app loading. At this point, around this time, I should be doing my auth in session, right? But it was being done over here, and I'm wasting time to do auth, and before auth, nothing can happen. So the point that Rajesh was saying, right, about how to sometimes even leverage native, that's a valid point. But over here, we're not even leveraging JavaScript. We're doing it much later when JavaScript started. So another point was this initial route was taking too much time. Over here, you can see deep linker, oops, deep link helper. Sorry, yeah, deep link helper was taking too much time. Deep links, as you know, that when you open a deep link from any random source, we need to resolve it, right? We don't know what this link is, and we can't just open random screen, home screen, or splash screen for all that file. So that was also taking too much time. So I went through the code and saw that, okay, the problem is, yeah. So the problem was that the session was not being eagerly loaded, right? Not lazily, but eagerly loaded. So what I did was, I could see there's some legacy code and whatnot, but it's ultimately a promise. So what I did was, I made it so that I can initiate the promise early on, but then actually use it whenever it's needed later on. So what this allows me is that when I start my app, right, then I can just simply call this config init and not care about the response of it. When I actually call it later in the app, it would be probably already in the fulfilling state or would be fulfilled by then. So without having to re-architect the entire app, just these 2-3 lines was enough to move something which is happening much later in the pipeline and loading it early. This is something which you would say preload does on native or on website, right? Similar things could be done with other things, right? So I went through all these performance optimizations, and you can see that now config happens much early, right? This was here and it moved over here, and chances are that by the time other things are needed to be done, it would be done, right? This is how you optimize waterfalls. So this was one thing that I did. Similarly with deep link, the problem was that it was calling multiple promises in sequence. So that could be done in parallel. And yeah, was it worth it? Yeah, it was, because that was the clear bottleneck that we solved, right? And it reduced it to half. So that was good. I did the again. I did the comparison a few months later, and it seems other apps also moved places. So Udaan actually moved here, but then other apps moved there, and still looks good. So nothing regressed on RUM as well as local testing. Okay, so then I'll skip some of these parts. You can check the blog, but I'll talk about perception also. So this is hardcore performance optimization, right? But what about perception? So sometimes you don't even have to do too much to improve performance. Swiggy, you all might be using, you might be using so many Blinkit apps, so many other apps. You would see that they have some interesting splash screens with animations and whatnot. You are entertained. You don't realize that they're masking their loading times, right? But you are entertained that, oh, this S is coming up or this Blinkit I is blinking, right? Those are cool things. And I'm like, oh, yeah, that's a easy win, low hanging fruit. Why not do this? On Android, you have to do something like this, that on old versions you can't use AVDs. AVDs is the format for doing animations, but on latest version you can. This is how they do feature API version detection with folder system. It was interesting to me. Implemented it, and now you can compare. So this looks very bland and boring. That is again entertaining you, so that it looks fine. This is something game engines do a lot, right? I'm sorry. This is coming up. Game engines use a lot of techniques to mask the loading screens, right? So this is one such way. Okay. Next, so lastly, I would like to say that this is hard problem to solve, and the other part about it is that it's harder to remember that these optimizations were done. So how to do that is basically good telemetry. So make sure that your team invests in having those markers, or if not nothing at all, just do this, that performance.now on the first line of your JavaScript code, and the first component that you want to be rendered, use layout effect, or if you're using class-based component did mount. That should be good enough to get that, okay, how much time did we spend before even rendering a React component, right? That should help you have some number. It doesn't even have to be absolute, right? You just need to check the relative trends. If it is going up or down, that's what's needed. Secondly, I was talking about how there's no lighthouse, but actually there is, and it's called flashlight. So that is another thing that you can look into. This will give you lighthouse-esque solution for your React Native apps, and it will also do a lot of cool stuff with metrics, right? It will give you CPU usage, bottlenecks, and whatnot. So do look into it if you are interested in improving your React Native apps stack performance. Okay. Thank you so much.
Thank you once again, Jyot.